I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi is a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics, including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. He joins us today to discuss the UAP phenomena, Von Neumann Probes, Freeman Dyson's Astro-Chicken, and Arthur C. Clarke's The Monolith. So, Avi, welcome back, sir. Again, it is truly an honor to be able to interview you, especially on a topic as speculative as unidentified aerial phenomena. So let me preface this by beginning to ask, how likely is it that UAP may actually be extraterrestrial in origin? Are there reasonable odds, or is our focus today more of a thought experiment?
Well, thanks for having me, and we could have saved a lot of time if you just refer to me as a farm boy, which is fundamentally what I am. All these titles are really not necessary and unimportant. With respect to the unidentified aerospace phenomena, these are reported by the government. There was a report from the Director of National Intelligence in June 2021 to Congress that led to the establishment of a new office in government and to a NASA study of these phenomena. And at the moment, the government is unclear. But the fact that they are unclear means that they do not suspect that these objects are of a threat to national security, because otherwise these events would be classified. So they just cannot figure them out. And of course, the government is not a scientific organization, and that means scientists need to get to the job of clarifying this matter and helping the government figure it out, and the society at large, because everyone is interested. And so that's why we established the Galileo project, where we build a suite of instruments that would monitor the sky at very high fidelity, so we can get clear images of these objects. And the first two categories that they may belong to are human-made objects like drones or airplanes, or natural phenomena like birds, bugs, meteors, thunderstorms. And these would be the two baskets where most of the events will lie. But it's sufficient to have one object that is none of the above for this to be extremely important for the future of humanity. For example, if we get a high-resolution image and see that there is a label on an object made on a planet near a distant star, and in addition, it maneuvers in ways that we cannot reproduce by orders of magnitude with our current technologies, it means that it's not of some adversary and it's not human-made. Therefore, we would conclude that this is worth further study. And of course, we don't have the protocol for how to respond to such a situation. It's just like finding a visitor in your backyard, but we need to respond promptly. And at the moment, we need to collect data that there is something of that type. There is another type of investigation we're doing with the Galileo project that I'm leading, and that is to interstellar meteors, to look at objects that burn in the atmosphere that came from outside the solar system. And there is one example that was identified in 2014, 4 years before the other interstellar object, Oumuamua, was identified. And this meteor appears to have moved faster than 95% of all stars in the vicinity of the sun. And moreover, it was tougher than 273 other objects in the catalog compiled by the US government. So it's tougher than iron, and it moved very fast before it arrived to the solar system. So the question is, what is it? And it could be some artificial object of another technological civilization, we plan to scoop the fragments from this meteor out of the ocean floor near Papua New Guinea in an expedition. And that is the way science is done. We need to collect evidence. And of course, if we find a piece of equipment that has buttons on it, I would love to press one of these buttons.
Yeah. Well, so today, one of the things, and again, I can't thank you enough for this interview. One of the things that inspired me was you recently wrote an article called What Came First, the Astro-Chicken or the Egg? And you broached the concept of UAP as possibly being von Neumann probes. So I wanted to start on this by asking for a description. How would you describe what a von Neumann probe is, and what advantages would they have for galactic exploration?
Let's consider what we have done. We launched probes into the solar system that will exit the solar system eventually. There are 5 of them, and they will go into interstellar space. Now, these probes will not be functional 1 billion years from now. So if there was a civilization like ours that launched probes 1 billion years ago, they would become space trash. Of course, most stars formed billions of years before the sun, so that's quite a likely scenario. So we might find a lot of interstellar objects like the meteor that I described that are not functional anymore, but they can burn up in the Earth's atmosphere, and we might find that they're made of some alloy that nature doesn't put together. Just from the composition, we can infer that they are technological in origin. The second category are functional objects. And if the unidentified aerial phenomena, at least one of them, is of extraterrestrial technological origin, they must be functional because they're hovering in the Earth's atmosphere. And of course, the question is then, are they replicating themselves? And that's what von Neumann envisioned back in 1948 when he came up with the concept of a probe that is able to land on a planet, perhaps, and use the raw materials there to replicate itself. And he was thinking about the concept sort of abstractly as an exponential process where one generation makes many probes and then the next generation makes many probes, and the population grows exponentially. And he was also thinking that there could be mutations, that every generation might be slightly different than the previous one. And as a result, you end up with evolution. And it turns out that, I mean, he thought about the idea a couple of years before the structure of the DNA, the double helix, was discovered. And it turns out that nature does exactly that. We see it in the biological world where generations keep evolving. And you can think of the same thing technologically, of systems that have 3D printers and artificial intelligence that are managing to use raw materials in order to replicate themselves. And that would mean that even one civilization that distributed one generation of probes out there could have filled up the Milky Way galaxy with probes if they went to all the habitable planets, including ours, Earth. So in that sense, it's a possible scenario that we might find unidentified objects in the Earth atmosphere that are replications of the early generations. Now, they may not have biological systems in them. They would be operating based on artificial intelligence and perhaps 3D printers, and they might be using some raw materials they find here on Earth. But the only way to find out, rather than speculate about it, is to look around. And that's what we are planning to do. Now, if these were obvious like birds are, then we would know about them. So presumably they're not as easy to recognize or identify as birds, but the government says we see some objects. Let's try and figure out what they are.
Yeah. What if it's okay, let me dive down just a little bit. So the article you'd written was about the Astro-Chicken concept that Freeman Dyson proposed. Now, if I understand correctly from reading through this, so Dyson really took von Neumann's idea of a biologically inspired self-replicating probe, and he kind of codified that, and he said, okay, this is how we might actually achieve that, right? And I think he was talking about like a hybrid biological machine organism. Is that kind of where it was?
Yeah, the only problem is that biology followed natural selection, and that was on the surface of the rock we call Earth. And once you launch biological systems to space, that's a very hazardous environment that can easily damage them. And for example, we know that if humans were sent unprotected to space, within a few years, a significant fraction of the cells in their brain would be damaged by energetic particles, cosmic rays. So we need to protect them. And it's not easy to go across interstellar space, also because of the long journey that is involved. And so Freeman Dyson thought about the solar system, but I think he was naive in invoking biology into those probes. It makes more sense to make them just purely made of electronics, the way we make artificial intelligence systems. I call them AI astronauts. And these are the ones we are most likely to encounter, given the long journeys across interstellar space. And the other thing is, you don't expect a probe to wait for guidance from the senders, because even signals of light take tens of thousands of years to cross the Milky Way galaxy. So there is just no way by which a probe will act based on guidance across interstellar distances. It has to be autonomous, and it could be provided upon its birth with the guidelines of or the guiding principles, just like we educate kids early on in their life, and then we send them to the world. And in much the same way, we can send the AI machine learning systems that will later on decide what to do and learn from experience in foreign environments. And if they evolve according to von Neumann, so that each generation might be different from the previous one, they might adapt to changing circumstances in different planets, around different stars. So they will not be identical. Each generation might look different, and we might see the latest generation that arrived here. So we should be open-minded. My point is, science should be guided by evidence, not by prejudice. And of course, if we say, let's assume we can guess the answer in advance and not look, that would be foolish of us, because nature has its way of surprising us. Nobody would have expected quantum mechanics to describe reality more than a century ago, and it ended up being the description of reality. So we can benefit from looking around, because maybe they know how to unify quantum mechanics and gravity. Maybe we learn something new that we don't fully understand about the universe by studying them. It's sort of like noticing a smarter kid on your block and learning from that kid.
Yeah. Well, one of the things, and again, for me, the von Neumann probe concept is so exciting. And one of the reasons is, if I'm doing the math correctly here, I mean, if we assume there are about 400 billion stars in the Milky Way galaxy, if you could send one self-replicating probe to each of them in less than 50 generations or replication events or doublings. And so if UAP are extraterrestrial, or as you said, even if only one of them is extraterrestrial in origin, it just seems like the economy of scale there makes it more likely that they would be this self-replicating kind of probe.
That's right. So just like natural selection, selects the fittest, survival of the fittest, you might think of technological selection, that those that replicate themselves and survive the harsh conditions of space are the ones that are most common for us to find. And as you say, it's a doable project within the lifetime of the Milky Way galaxy, in the sense that the Milky Way existed for 10 billion years. Now, if you use chemical rockets to traverse the entire Milky Way galaxy, it takes about 500 million years. Just the existing chemical rockets that we are able to produce. And that leaves another 500 million years, let's say, for producing replicas of whatever lands on a planet, which is a very long time if you think about the natural evolution. So in principle, I mean, the transition, let's say, from single cell organisms to multi-cell organisms, that what happened on Earth naturally, within a couple of billions of years after the first forms of life appeared. And If you do it technologically, you can definitely do it in 500 million years in a more orchestrated way. And so, so that within 1 billion years, you can pretty much fill up the Milky Way galaxy in terms of travel time. And then, as you say, it's 50 generations would make enough probes to fill up the entire Milky Way. And it shouldn't be too difficult if you direct those probes to the habitable regions where life may exist. It depends really on the blueprint of these probes. What are they trying to find out and what are they trying to accomplish? And if you think that the most valuable resources are in the habitable zones of stars, you will target those probes to the inner regions of planetary systems. And by the way, that would save a lot of time because instead of populating the entire planetary system, you'll just focus on the inner part.
Yeah. Well, so devices like this have been portrayed in science fiction. Now, one example that's close to my heart is the Monolith in Arthur C. Clarke's 2001: A Space Odyssey. And that seems like that concept was very similar to this von Neumann probe idea. Is that, do you think that's a good example that people can look at?
Well, that's an example, but of course, now we know of technologies that would make it quite different. If you think about an AI robot with a 3D printer, it might look quite different than envisioned decades ago. And of course, that's our imagination shaped by the current technologies, but these technologies are evolving exponentially, especially on the AI front. So I would be hard pressed to imagine how it would look like. I think if another civilization did it already, then we better look around and figure out what it looks like rather than try and imagine what it might look like for us. And that's a way of looking at our future. And perhaps we can get a jump start into our future by copying from a smarter kid on the block. It may feel like cheating in an exam, but if we can get to the answer 1 million years in advance, so be it. I would rather know what it is.
Well, that's a good point. And and there's no reason to say that they didn't cheat on the exam too in the past, right? So
yeah.
now so the Monolith in 2001, that had been here in the movie plot, had been here for a long time, observing and maybe even directing the evolution of life on Earth. So one of the things I that kind of came to mind was, as NASA begins this journey back to the moon in 2024, would it be worth them searching for some kind of observation probe or communications relay along those same lines?
Definitely. The moon is interesting, similarly to Mars in a way, because it doesn't have an atmosphere, the moon, and it doesn't have geological activity. So anything that landed on it, that crashed into it, is preserved. It didn't burn up in the atmosphere, and it wasn't mixed with the inner parts of the moon. So within a layer of about 10 meters deep, everything that crashed in the moon should still be there. So you can think of it as a museum. And we've never checked the shelves of this museum. We never looked at the surface carefully. And it's possible that there are some relics, and they could have arrived from a space trash associated with some equipment that stopped functioning, that collided with the moon by chance, and we can find it. Or there is also the possibility that there was a civilization here on Earth, that Apollo was not the first lunar landing mission. And if so, we can find some footprints there that have nothing to do with the astronauts we sent. So I think we should just search, and it's sort of like an archaeological site that we can look for any evidence that something collided with the moon.
Yeah, yeah. And actually what you just mentioned, that reminded me of another book that I was a child. It was it James P. Hogan's Inherit the Stars? And that was a big one for me. So well, so let me touch briefly on some of the cultural aspects of this, because I think this is really intriguing as well. I've met a few people recently since the UAP story has been in the news, who are still thinking of ET or extraterrestrials along the lines of space invaders, like in the movie Independence Day. But given the level of technology required for galactic exploration, do you think it's more likely that we would see something like Carl Sagan's Contact or maybe Arthur C. Clarke's 2001?
No, the way I think of this is that we developed our modern science and technology only over the past century. And that's one part in 100 million of the lifetime of the Earth, the age of the Earth. So the chance that we will meet another civilization exactly the same technological phase as we are encountering right now is very small. It was naive of us to look for radio signals just because we discovered radio communication last century. Because most likely either they are very primitive relative to us, the way we were a million years ago, or they are very advanced relative to us. These are the most likely situations. Now, if they are primitive, we will have to go to an exoplanet and visit the jungles and search under the trees to see those primitive tribes that live there. And that's a very tedious endeavor. We need to, first of all, go there, which takes a long time, and second, land there and start searching. So that's very tedious. Alternatively, if they're much more advanced than we are, then we just need to look around. Okay, so it's possible they already sent probes that are in our vicinity. That sounds much more like fun. It's like searching for objects from the cosmic street in your backyard. Now, of course, when you see an unusual object, the first thing that your family members would say is, it's a rock, because we had a lot of rocks in our backyard that we looked at in the past. So anything coming from the street must be a rock as well. And guess what? That's exactly what my colleagues said about the first two interstellar objects that were discovered, objects from outside the solar system. One of them was the meteor I mentioned in 2014, and the second is Oumuamua. They said it's a rock, but then it looked as if it doesn't have the same characteristics as asteroids or comets that we had seen before in the solar system. So they said, well, it's a rock of a type that we've never seen before. Just imagine a beach ball landing in your backyard, and people would say, oh, it's a rock of a type that I've never seen before, or a tennis ball. So my point is, we should be a little more imaginative. If we see objects that are not similar to anything we've seen before within the solar system in our backyard, we should allow for the possibility that they're technological in origin and collect more evidence about them. And that's the way to proceed. And rather than guessing or speculating or dismissing the idea, we should examine it. And of course, my colleagues say extraordinary claims require extraordinary evidence. My point is, extraordinary evidence requires extraordinary funding. Though the search for dark matter that was conducted over 50 years, we don't know what most of the matter in the universe is. We invested billions of dollars. We haven't found it yet. So if we invest billions of dollars in the search for technological equipment from other civilizations, because we produce such equipment that we sent into space, so it's a very natural thing to look for. If we search for several decades and invest billions of dollars and not find anything, we would just be at the same stage as dark matter searchers are right now. So why would dark matter search be part of the mainstream and UAP or the search for unusual interstellar objects be at the fringes of science? That doesn't make much sense to me, especially given that if we find equipment from another civilization, that would have huge implications for the future of humanity.
Yeah, yeah. Well, and it's interesting. I mean, when you said it's just a rock, but one of the popular themes in science fiction was actually hollowing out rocks to use as interstellar spacecraft. And one of the reasons is it's economical, I guess, right? To hollow them out, and it provides a lot of shielding. So there's one advantage to that, and and then there's also this idea of maybe it's something along the lines of Rendezvous with Rama, right? Which was
right.
Yeah,
Definitely. So science fiction serves an important role of expanding our imagination, but I'm a scientist and I don't like science fiction because very often it violates the laws of physics. And so far we see the laws of physics to hold everywhere in the universe. So I'm much more in favor of looking around and learning what the reality, the neighborhood, the cosmic neighborhood that we live in is like. So rather than talking about science fiction, doing real science, and that may be better than any fiction because we are often surprised. Dark matter, guess what? we cannot find it in the solar system. People used to think that the universe as a whole is made of the same matter as we find in the solar system. In fact, before about a century ago, most astronomers thought that the sun is made of the same composition as the Earth. And that ended up being wrong, okay? So we tend to think that what we find around us is what is everywhere. So then we realize, oh, most of the matter in the universe is not the matter that we find in the solar system. And now the third revolution is perhaps that some of the objects that enter the solar system, these interstellar objects, are not what we found in the solar system before. So to me, it's an eye-opening exercise because it's possible that some of them are artificial.
Yeah. Well, Avi, I want to thank you again so much for your time. And let me close by asking directly about the Galileo project, because I know that you have invested so much time and energy and passion into moving that forward. How is that going? And how can people help to support that?
Yeah, so the Galileo project is 1 year old, and we just had a conference where we all went to the roof of the Harvard College Observatory to look at the suite of instruments that was constructed to monitor the sky for unidentified objects. And it will start operations in the coming months, and hopefully we'll have data before the next annual conference of the Galileo project. We are currently funded at a few $1 million from wealthy individuals who came to the porch of my home after being inspired by the vision of my book, Extraterrestrial. And I have actually a sequel, and the next book will come out in June 2023. I just finished it today, actually. Wow. And so we can scale up the activities of the Galileo project, which include monitoring the sky, include looking at the relics of meteors that came from interstellar space, like the one near Papua New Guinea. And it also includes rendezvousing with the next Oumuamua. And if we receive funding at a level that is 10 times bigger, that would allow us to expand our operation. We have about 100 people involved, but there are 800 people who volunteer to help us, and many more who are very excited about the project. So it's all a function of the funding level that we have. And if we get more funding, we can increase the scope of the operation. And as I said, I think it deserves funding at the level of the search for dark matter, which was billions of dollars over the past several decades. And that means currently tens of millions of dollars per year. And I very much hope that we will get there.
Wonderful. Sir, thank you again so much for your time today.
My pleasure. And anyone interested in contributing to the Galileo project, please reach out to me, or have a look at the website where we have a link to a possible funding form that anyone can fill. Thank you.
Thank you.